So next topic is mean life or average life of a radioactive sample. So the atoms of a radioactive sample, as we know, are constantly decaying or disintegrating, but they are not disintegrating at the same instant of time. Some will disintegrate earlier while some will disintegrate later, and we cannot predict beforehand which of the atom will disintegrate at the present instant of time. Okay, it is completely random and it is completely probabilistic. Okay, so we can say that the lifetime of a nuclide may vary from 0 to infinity. Okay, so as soon as we start observing a radioactive sample, if a nuclide decays or disintegrates instantly, then its lifetime will be 0. Lifetime is for how long a nuclide remains undecayed. Okay, so if the nuclide or nucleus disintegrate instantly as soon as we start observing, then it has a lifetime of 0 second or 0 day or 0 year, whatever. And if we keep observing and the nucleus is not decaying, maybe it decays after 1 year, then it has a lifetime of 1 year. If it decays after 2 hours, then it has a lifetime of 2 hours. If it decays after 10 years, then it has a lifetime of 10 years, etc. Okay, so and if it remains undecayed for a long interval of time, and we keep observing the radioactive sample and this particular nucleus had not decayed yet, then we can say that the lifetime of the nuclide or the nucleus has an infinite lifetime. Okay, so what we can do, as in a radioactive sample, various atoms have various lifetime, they decay at different instant of time. We may take average of or mean lifetime of all the nucleus present in that radioactive sample. So what will be the average or mean lifetime of the atoms in a radioactive sample? It is the sum of the lifetimes of all atoms present in that radioactive sample divided by total number of atoms in that sample. So the mean life of average life, generally we may use the symbol tau. Okay. So next we'll find an expression for this mean life or average life of a radioactive sample. So let there be n0 number of atoms present in a radioactive sample initially, that is at t equals to 0. Now, out of this n0 number of atoms, different number of atoms disintegrate after different time interval. Okay, so let dn1 out of n0 number of atoms, let dn1 number of atoms disintegrate after a time interval of t1. Therefore, this dn1 number of atoms have a lifetime of t1. For example, there are 1000 atoms. Out of them, 50 atoms are disintegrate that decay into a new type of atom after 2 minutes. So, this 50 atoms out of 1000 atoms have lifetime of 2 minutes. And then there are like 60 atoms which decay after 3 minutes. So, these 60 atoms have lifetime of 3 minutes. Okay. So similarly, there are other dn2 number of atoms which decay after a time interval of t2. Therefore, they have a lifetime of t2. Okay, and then dn3 number of atoms have lifetime of t3 in this way. Okay. So therefore, what is the total lifetime of all these atoms? Okay, it will be as out of dn1 atoms, each has a lifetime of t1, then the total lifetime of dn1 atoms is t1 into dn1. Similarly, each of dn2 atoms has a lifetime of t2. So the total number of this dn2 atom is t2 into dn2. Similarly, each of dn3 atoms has a lifetime of t3. So this dn3, all dn3 atoms has a total lifetime of t3 into dn3. So total lifetime of all the atoms will be t1 into dn1 plus t2 into dn2 plus T3 into DN3 plus, if we consider another lot, T4 into DN4 and so on. Okay. Now what is the total number of atoms? Total number of atoms will be sum of all these lots, DN1 plus DN2 plus DN3 plus DN4 and so on. Okay. So what will be the mean lifetime? TA, or you can use tau. It as we know, it is the sum of total lifetime of all the atoms, that is the sum of lifetime of all the atoms divided by total number of atoms. So what is total lifetime of all the atoms? This one. So T1 DN1 plus T2 DN2 plus T3 DN3 so on, divided by DN1 plus DN2 plus DN3 and so on. So this T1 DN1 can be written as summation of Ti DNI divided by, if we take sum of all this group of atoms, what we get? We get the total number of atoms present in that sample, which is, if I write summation over DNI. Now summation over DNI is the total number of atoms present in that radioactive sample, which is N0.